So class, today we are going to learn the conversion of decimal into octal numbers. In book 2, previous class, we used to repeated division method to convert decimal into their binary equivalents. We can use the same method to convert decimal into their equivalent in the octal number system. When converting decimal into octal numbers, we divided the decimal numbers by 2. जब हम डेसिमल को ऑक्टल नंबर्स में कन्वर्ट कर रहे होते हैं तो हम उनको किस चीज से डिवाइड करते हैं 2 से डिवाइड करते हैं here we divide the number by 8 ठीक है now अब यहाँ पे जब हम डेसिमल को ऑक्टल में कन्वर्ट कर रहे हैं तो हम डेसिमल नंबर्स को 8 से डिवाइड करेंगे ठीक है because the base of octal number is 8 we keep dividing the quotients till we get quotient less than 8 हम तब तक हमारे क्वेश्चंस होते हैं the answer we are getting फ्रॉम द डिवीजन उसको हम तब तक डिवाइड करते रहते हैं जब तक हमारा आंसर जो है वो 8 से कम नहीं आ जाता when they record the remainders from the bottom to top gets the answer now when we have the quotients less than 8 so what we do we just note down the answers but we write it into the decreasing side like हम उसको bottom से top में note down second note from top to bottom हम उसको उल्टा reverse में लिखते हैं for example example number 1 from page 5 have a look everyone convert 45 base 10 into octal equivalent now here what they have done they have the number 45 they divided it to 8 and they got the remainder 5 with the number 5 so 55 was the answer with base 8. Example 2 is convert 228 base 10 into its octal equivalent. So what came here that number 228 was divided by 8. So first we got 28 as answer with the remainder of 4. Then when we divided 4 with 8, then when we divided further 28 with 8, what we got 3 as an answer. So when we note down all the remainders, what the answer is there? It's 344 base 8.
In the base 8 system. Well, the first thing you need to do is take the number that you have and divide it by 8. So let's use a calculator to do that. Now, 394 divided by 8 is 49.25. Now, what we need to do here is we need to identify the remainder. So we have 49 and then remainder. In order to identify it, take the decimal value, the numbers after the decimal point, that is 0.25, and then multiply it by 8. So 8 times 0.25 is 2. So we have 49, remainder 2. Now, take the 49 and then divide that by 8. 49 divided by 8 is 6.125. So this is going to be 6 remainder and then multiply 0.125 by 8. So 8 times 0.125 is 1. So we have 6, remainder 1. Next, take 6 and divide it by 8. Now, because 6 is less than 8, we could say that 8 goes into 6 0 times with a remainder of 6. If you take 6 divided by 8, it's going to give you 0.75. So this number gets transferred here. And then if you multiply the 0.75 by 8, it's going to give you 6. And so you get a remainder of 6. Now the way you read your answer is you read it starting from the most significant digit to the least significant digit. So you read the remainders from the bottom to the top. So the first number is a 6. And then after that, we have a 1. And then we have a 2. And this is in the base 8 system. So 394 in the base 10 system is equal to 612 in the base 8 system. And so that is how we can convert a decimal number into an octal number. Now let's work on another example. So try this one, 784. Go ahead and use a calculator to convert it.
Now we are going to move further towards conversion of decimal numbers into hexadecimal values. On page number 6 of your book, you can see that we can also convert decimal numbers into hexadecimal values using the repeated division method. The difference here is that we divide the numbers by 16 instead of 8. As hexadecimal की जो base value होती है वो क्या होती है 16. So हम यहाँ पर numbers को 8 की बजाय 16 से divide कर रहे होते हैं. We also need to remember that in the hexadecimal system, values from 10 to 15 are represented by letters A, B, C, D, E, and F respectively. So 10 is represented by A, 13 by D, and so on. You can have a look at the chart in 1.3 figure. ठीक है, उन्होंने एक चार्ट दिया जिसमें उन्होंने डेसिमल इनटू हेक्साडेसिमल वैल्यूज को शो किया है कि जब कन्वर्ट होती है तो क्या आता है, हम उनको किस तरह रिप्रेजेंट करते हैं. Now move further towards example 1. Convert 55 base 10 into hexadecimal equivalent. Now we have number 55. We are going to divide it with 16, and when we divide it with 16, we get the answer 37 base 16. As 16 threes are, they just divided it, and then the answer is 37 base 16. In example 2, they have converted 225 base 10 into hexadecimal equivalent, by which the answer was 14 and the remainder was 1. So as the number is above 9, so we are going to change the value into alphabets. See, so the when they got 14 into 1, so the value of 14 in the chart given in figure 1.3 is E. So we are going to write the answer E1 base 16. Further, to explain it in detail, I'm sharing our videos. Have a look at it.
How to convert a decimal number to a hexadecimal number. So how can we do this? Well, first you need to understand that the decimal number is based on a base 10 system. For example, let's say if we have the digit 49. The first digit can be anything from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the same is true for the second digit. We have 10 options to choose from. So the decimal system is a base 10 numbering system. Now what about the hexadecimal system? Notice that it's composed of two words, hexa and decimal. Hexa corresponds to 6. Decimal, as we can see here, corresponds to 10. And so if we add 6 and 10, this will give us 16. So the hexadecimal numbering system is a base 16 system. Now, you need to know the numbers that corresponds to the hexadecimal system from the decimal system. So the number 1 in the decimal system has the same value in the hexadecimal system. So 1 corresponds to 1. 79, which is a base 10 number, that's a decimal number, into a hexadecimal number. How can we do this? The first step is to take 479 and divide it by 16. So we said we're going to use a calculator for this, so let's go ahead and do that. 479 divided by 16 is 29.9375. So here we have an integer of 29, and then we need to find the remainder. To find the remainder, multiply 16 by 0.9375. So 16 times 0.9375, that will give you a remainder of 15. Then you start with this number, 29, and divide that by 16. So let's move on to the next row. So 29 divided by 16, that's equal to 1.8125. So that's one remainder, and to find the remainder, multiply 16 by 0.8125. And so that will give you remainder 13. And then you need to take the 1, divide that by 16. Now we really don't need to do the division here because 1 doesn't go into 16. 16 doesn't go into 1. So we could say it's 0, remainder 1. But if you did it, let's say if you taken 1 and you divide it by 16, you're going to get 0.0625. So looking at this number, you'll see that we need to put a 0 here. And then if you multiply 16 by 0.0625, you'll get 1. But you really don't need to do the division. You can see that 16 goes into 1 0 times with a remainder. It's 1, 13, and 15. So we had 1, so we had 1, 13, and 15. So the remainders, you want to convert them to hexadecimal numbers. 1 as a decimal is 1 as a hexadecimal. And based on the chart that we wrote earlier, 13 corresponds to D and 15 corresponds to F. Now 1 is the most significant digit and F is the least significant digit. So we need to write it